Hello, everybody. Today I'll be discussing decision support systems for energy engineering. The parts of this presentation is, of course, an introduction to DSS or decision support systems. And we have strategies and tools, other advanced DSS methods, disadvantages and advantages, and of course, the conclusion. First, let's go to the definition of DSS. So, DSS facilitate and provide guidance to the decision-making process. And although they heavily rely on computers, they do not intend to replace humans in the decision-making. These are the basic components of a DSS. We have the model management system, which stores the models. We have the knowledge base, which stores the dynamic information or data. And we have the user interface, where the user is able to control the DSS. And there are many applications of DSS, and organizations invest on DSS because making decisions usually requires lots of computations and lots of data. And computers are very good at making computations and processing data. They also invest on DSS because of the high consistency, and sometimes when we need to make rapid decisions, like for example, during natural disasters. And DSS can help us support to make faster decisions. So some of the applications include in medical, we have mapping and directions. This is for flood management. We have real estate and credit loan verification and business management. We have engineering projects and for agriculture. So a concrete example of DSS is in GPS planning, route planning. A DSS can recommend the quickest route between two destinations. Say, for example, by monitoring the traffic, calculating the distance. For agriculture, DSS can recommend to farmers the best time to plant, fertilize, and reap their crops. How about DSS applied in energy engineering? Let me share a brief history. It was first used in the 1960s to investigate problems in oil and gas exploration. And in the 1970s, the first energy models, which focuses on energy economy relationships, were started. And then during this time, they only use a single criteria in the decision in DSS. And then in the 1980s, it was used already for sustainability, and environmental concerns were also considered. Now they use a multi criteria. So what does it mean to have a single versus multi criteria? For example, for single criteria, they just want to calculate, say, the maximum energy that can be delivered. But for multi criteria, aside from that energy, say, they also want to consider the carbon footprint, the water use, land use, etc. And in the 1990s, now DSS is considered in policy making. The use of DSS in energy engineering is now considered as an obligation, since decisions in this field involve multiple interests and factors, and it's not socially acceptable to just consider the interest of a few. Say, for example, you are a power plant, a power company. you also have to consider the communities, the environment, and it's not so morally um, ac- acceptable that you just use DSS to calculate decisions that would benefit you, the power as the power plant owner. So the stakeholders that usually use DSS are individuals, institutions, government, communities, investors, etc. And in energy engineering, there are many applications, and these are for energy policy analysis, calculating the impact of, say, a policy, electric power planning, technology choice and project appraisals, environmental impact analysis, and renewable energy investments. Those are just some of the applications. There are many publications in literature related to DSS in energy engineering. For example, we have DSS applied in upstream oil and gas sector. We have DSS applied in renewable energy investments, and DSS applied in understanding risks and uncertainties in energy and climate policy. So those are some global international publications that I got from the literature. Locally, I found these studies. So we have DSS applied in renewable energy mapping in the Philippines. And we also have from our very own Dr. K and Dr. Tan ranking negative emission technologies under uncertainty. So although these are not necessarily about energy engineering, but we all know that um, a big amount of carbon dioxide is released due to power generation. So the negative emissions technologies are indirectly, or we can say directly connected to energy engineering. Let me move on to the decision types. The first type of decision is the unstructured decision, and these are chaotic, hard to predict, subjective, abstract, qualitative. And for these types of decisions, it's best that a human makes the decision. For example, marking essay exams, if you're a teacher, um, marking essay exams would really depend on your preference and subjectivity, or evaluating art. Those are examples of unstructured decisions. Next is on the opposite side of the spectrum, we have the structured decisions, and these are predictable, objective, can be solved mathematically, and they are well defined. Examples are, say, marking multiple choice exam. So we can let the computer do that. It can be automated. Or if we want to calculate a person's BMI or body mass index, we just input the height and weight, and the computer can do that for us. So for these types of decisions, it can be left to computers without human intervention. And somewhere in the middle, we have the semi-structured decisions. So um, from the name itself, it involves both unstructured and structured decisions. It involves planning decisions and usually have variety. And for these types of decisions, it's best approached using a decision support system. For example, in deciding what to wear when you go outside, you may look at the weather forecast as a form of ADSS. But ultimately, you are the one to make the decision of what you will wear. But there's a small risk that the weather forecast will not come true because it's a forecast. So that's an example of a semi-structured decision wherein we used a DSS, which is the weather forecast, to make our decision. Some DSS strategies. So we have statistics using statistical models. We all know this, that it establishes relationships between factors and responses. Then we have optimization. Here, we use mathematical procedures to find the maximum or minimum of a function. For example, we want to maximize profit or minimize the input of raw materials. And then we have sensitivity analysis. It how the variation in the input impacts the results of the output. It is used for what if analysis. Next, we have heuristics or rules of thumb. And then forecasting, this is where we use regression models and time series in planning. Lastly, we have satisficing, which is a combination of satisfying and sufficing. So what does it mean? It's aiming for, instead of aiming for the optimal solution, which is done in optimization, in satisficing, we just aim for an adequate solution by looking at an acceptability threshold. Okay, so just some pictures to show the strategies. We have statistical models, wherein we have an X and Y, and then we have optimization and sensitivity analysis. So going back to optimization, are you familiar with response surface methodology? So we can use that to make to find the optimum. We have heuristics, forecasting, and I just want to share this picture on um, satisficing to explain it further what it means by comparing it with maximizing. We can describe a person if a person is a satisficer or a maximizer. For a maximizer, it seeks the best solution or decision. It compares, the person compares decisions with others. The person spends more time and energy in making the decision, and usually the person is unhappier with the outcomes versus a satisficer. For a satisficer, the person accepts a good enough result. The person doesn't obsess with other options and can move on after deciding, and the person is happier with the outcomes. Which one are you? Are you a maximizer or a satisficer? Because personally, I am a maximizer, but then now I realize that it's better to become a satisficer. Now let's move on to the different DSS tools from the simplest to the most complex. Spreadsheets are actually the simple but powerful DSS tools. We can use it for sorting, for what if analysis, for sensitivity analysis, lookup and search calculations, and graphical representation. In fact, making graphs, that's already a DSS. I'm sure you're familiar with Excel sheets or Google Sheets. Next is relational databases. And these are done by linking two or more spreadsheets. What are the advantages over a single spreadsheet? Of course, obviously, it can handle more data with increasing complexity and can do more calculations. So an example is an SQL database. Next are expert systems. So for this tool, it mimics the intelligence of an expert. What are the advantages over spreadsheets and relational databases. Expert systems and what are the advantages over humans? Expert systems have more attention to detail, of course, and versus human errors. And they are can be accessed all the time. Unlike humans, we cannot human experts we cannot call them when it's out of office hours. And then it can be multiple users can access the expert system. Unlike in humans, we have to consult to consult a human one by one, and an expert system does not leave the organization, does not resign. And in energy engineering, expert systems are used in energy management systems. What are the parts of in an expert system? We have the knowledge base, the database of facts, not included in the picture though. We have the inference engine and the user interface. So the knowledge base contains the set of rules such as if and then statements. Of course, mimicking the knowledge, the decision-making process of an expert. So an expert has years of experience making that decision, and the expert system mimics that. The database of facts stores the data or the current situation. The inference engine links the two so that it can come up with a conclusion. And finally, we have the user interface, and that is what we see. So if we have the human expert, and then the knowledge engineer, which made the expert system, we can so they work together to make this expert system. So any person who is not an expert in making that decision in that area can access the expert system to consult the decision. We have artificial neural networks. That's another tool. Okay, I'm sure you're familiar with ANNs or artificial neural network. What is the advantage over expert systems and spreadsheets and database relational databases? ANN have self-learning capabilities. Okay, unlike in the previous tools, if we want to adjust it, we adjust it manually. We adjust the if and then rules, etc. But we have to give the ANN an appropriate deterministic, or that means true data, and we have to provide it with the quality data. Nevertheless, it self-learns, so it can learn autonomously, and that's an advantage of ANNs. Moving on to advanced DSS methods for energy engineering, we have so many techniques and methods. These are just a few, and we will not discuss all of these. I just selected a few. One is LCA, which is it has been discussed by our classmate. Next is operational research. If you were my classmate last term under Dr. Tan and Dr. K, we actually did this. We made objective functions, and we we made constraints, and the models can be solved by linear programming or nonlinear programming or mixed integer programming. So these are logical relationships among variables. Next, we have cost-benefit analysis. In this method, we represent the cost as an equivalent money value, and we also represent the benefit as an equivalent money value and we compare the two. So if the benefit is greater than the cost, then that means that the project or whatever we're deciding on, it means that we can pursue the project. For Monte Carlo simulation, in this method, random sampling is done together with statistical analysis. And the results of each iteration or random sampling, the mean is determined so that and the number of iterations can vary from hundreds to thousands so that we can determine the mean probability of the occurrence of the event. It's usually used in upstream oil and gas for risk assessment, reservoir evaluation, etc. Next is the multi-criteria decision-making analysis, or MCDA. And under that, we have methods such as weighted sum, model, and analytical hierarchy process. Like I mentioned earlier, in MCDA, we consider problems with multiple attributes like technical, economic, social, legal, and environment. As compared to single criteria, we're just um, looking at, say, for example, just energy, amount of energy produced. But in MCDA, we're also looking at the environment, the socioeconomic, etc. And that's the way to go because, like I said, it's not responsible to just consider the um, concerns of one group. And under that, we have the weighted sum, which finds the weight sums of each alternative. So for the alternative which gets the highest points, then it means that alternative is the best. For the AHP, it breaks down the decisions to a hierarchical structure with a goal on top, and followed by the criteria, sub-criteria, and alternatives. And then the user makes a pairwise comparison and evaluation between the alternatives. That's another way of finding the best alternative. Next, we have the fuzzy logic analysis. We already, if you were my classmate last term, we tackled this. And it deals with, fuzzy sets deals with membership of the variable. I remember the example of Dr. Tan last term would be for the term young. How do we determine if a person is young? We can say, for example, young includes ages 0 to 25. So there's a membership variable. It's usually used in energy sector for reservoir characterization, drilling, permeability, etc. Next is artificial intelligence, like ANN, the one I mentioned. I'm sure you're familiar with that. So aside from artificial neural networks, under artificial intelligence, we also have support vector machine, decision trees, and I'm sure you're familiar what is AI. Next is the advantages and disadvantages of using a DSS. Obviously, it speeds up the decision-making process because the computer handles all the data and computation, making it more efficient. It automates the process, it's flexible, it helps user. So this is the best advantage in my opinion. It helps the user make intelligent and informed decisions. But there are limitations. DSS heavily rely on the integrity of the data. The data has to be accurate and good so that the results would also be accurate and good. There's lower accountability. Say, for example, you're the manager and the decision flopped. You can just say that, well, that's what the DSS recommended. It's hardware dependent. So you need to invest on a high computer computing power, since you need to do that, may be costly and requires capital investment. Aside from buying the computer, you have to buy the I mean you have to hire people to make the DSS, and that's also expensive, the labor for that, because you're hiring professionals. It cannot make subjective decisions. What if the decisions would impact humans? What if there are stakeholders that what if there's inequality? It lacks ethics. Concluding the presentation, we have decision DSS facilitate and provide guidance to the decision making process, and it has many applications in energy engineering, including oil and gas, renewable energy investments, evaluating energy policy, etc. And we have shared a number of DSS strategies, and the DSS tools. We have spreadsheets, relational databases, expert systems, ANN. I also shared other DSS methods, such as we have operational research, cost benefit analysis, etc. I shared the advantages and disadvantages of DSS. And right now, ongoing research is being done on DSS in the field energy engineering. And if you are interested to do this as your research, I highly recommend it. It's a very exciting and interesting field. That ends my presentation. Thank you very much. I'm now ready to answer your questions.